All right, if you guys didn't get 6.29 for this chi-square problem about the fish, I'm going to go through it real quick and we can figure out where you went wrong. So reading the question, it says that they stocked this pond. 10% of the fish they put in there were bass, 40% were crappie, and 50% were bluegill. Whenever they caught those fish and counted them, here's the numbers that they had a year later after in that pond, the snakehead fish was also introduced. Okay. So in this first column, we're going to put our categories. So I'm going to put, we have bass, crappie, and bluegill. Now, if you remember on our chi-square formula, we have O, and then it says we need E, O minus E. You're supposed to take that and square it. So this is O minus E squared. And then O minus E squared divided by expected, okay? And then eventually we're going to sum those up. So our observed are pretty easy because we counted and we observed 55 bass, we have 150 crappie, and then 220 bluegill. Now, we're wanting to see if the percents change. And they're giving us, here's the initial percents. So if the snakehead fish was affecting the percents, then we would be getting some numbers here that are way off from these initial percents. So our expected percents, we should still find 10%, 40%, and 50% if that snakehead fish is not affecting our fish populations. Okay. So hopefully you put those percents up in the corner because I told you to do that. And that's a common thing to do that's going to help you make sure that you're solving your problems correctly when we're working chi-square problems. Now, this is where students mess up quite a bit. They like to take 10% of 55 or 40% of 150, but that's not what you do. You need your total number of fish. So if you add this up, in that lake, there was 425 fish, okay? That was after a year because we caught them. 10% of that. So we do 10% of this total of 425. And that's the number that you're going to put here. So you can either do 0.10 times 425, or you can put 10% in your calculator and then multiply that by 425. Either way, you should end up getting 42.5 would be expected. 42.5 bass if 10% of this whole population were those bass. All right, now we're going to do 40% times 425, or you do 0.40 times 425. That gives us 170. And then 50% times 425 will give us 212.5. All right, now we just got to follow the directions. So O minus E, 55 minus 42.5 gives us 12.5. This one is negative 20, but remember, we're about ready to square it. So that negative really isn't important in this case because we're about ready to get rid of it. So you can put negative 20 or 20, it doesn't matter. And then the difference between here and here is 7.5. Now, when you go to square them, squaring isn't 12.5 times 2. It's 12.5 times 12.5. And that is 156.25. 20 times 20, or 20 squared, is 400. And then 7.5 squared is 56.25. Okay. So now this number, like 156.25, is the top number in this next calculation. So I like to write it out just so that I don't make mistakes. So I'm going to take that number divided by the expected. So you're going to come over, and the expected that we're expecting 42.5 bass. So now I'm going to take this number, 400 divided by the expected is 170. 56.25 divided by the expected, which is 212.5. And now, since you have them all written down, then you can go ahead and calculate. And I think you're less likely to make mistakes if you go ahead and just write them all down and then calculate. This gives us 3.68. 400 divided by 170 is 2.35. 56 divided by 212.5 is 0.26. Okay. From there, remember in our formula sheet, we had that funny looking E, which means sum. So we're going to add these values together. I like to put a little plus here and a little line here. Just always be consistent about how you do them. Little things like this is going to, again, help your brain remember how to do these problems months from now. And so those add up to 6.29. All right, you should be able to use your notes and complete the rest of those problems.